What if the most precise engineers on Earth weren't using computers or even writing, but were still aiming stone with the confidence of someone who could see invisible lines in the sky? You're standing on an ancient plain. No cranes, no metal tools, no compass that you recognize. And yet, the monument in front of you points with eerie accuracy toward a place the sun will rise only on 2 days of the entire year. Another site, thousands of kilometers away, locks onto true north as if it had been calibrated. Another matches the rhythm of the moon. It feels impossible. So you start asking the uncomfortable question: how did prehistoric builders aim so precisely? At first, the simplest answer is the most unsettling. They watch the sky, a lot, for a long time. Because the sky is not random. The sun rises and sets in patterns that drift through the seasons. The moon wanders on a schedule with quirks you can learn. Certain stars circle around an invisible pivot point. If you pay attention, nature gives you a ruler. And prehistoric people were paying attention like their lives depended on it, because they did. Seasons meant food or famine, a missed migration, a failed planting, a winter you weren't ready for. If you could predict time, you could predict survival. Then you notice another fact. You don't need complicated math to make a straight line. You need tension, a cord pulled tight, 2 stakes, a sightline. Humans have had string, fiber, rope, and wooden pegs for a very long time. With those alone, you can lay out a circle. You can bisect an angle. You can keep things square enough to build. And there's something else. The big monuments were not built in a weekend. Many were built over generations. If you are a community returning to the same sacred spot year after year, you're not doing a one-time measurement. You're running a long experiment. You can mark where the sun rises on the horizon on the day the river floods. You can place a stone. The next year, you check again, you adjust. Over decades, you collect a data set with your feet. Suddenly, the mystery gets worse, because this actually makes sense. Take Newgrange in Ireland. Built around 3200 BCE, older than Stonehenge. For a few minutes around the winter solstice, sunlight slips through a narrow roof box and travels down a long passage to illuminate the inner chamber. This isn't a vague, points kinda toward winter. It's a deliberate beam of light. Or look at Stonehenge. Its main axis aligns with the summer solstice sunrise and the winter solstice sunset. The stones aren't just placed, they're arranged like a statement. We know when the year turns. Then there's the Great Pyramid of Giza. Its sides face remarkably close to true north, south, east, and west. The error is tiny, minutes of arc. And this was built around 2560 BCE, long before magnetized compasses. The pyramid looks like it's plugged into the grid of the planet itself. Now connect that with something even stranger. Similar precision shows up in different cultures, different continents, different eras. From the Americas to Europe to Africa, you keep finding buildings that seem to care about cardinal directions, solstices, equinoxes, and lunar cycles. Coincidence starts to feel less satisfying. Because aligning a building is hard. Aligning a massive stone complex is harder. Aligning it without being able to see true north directly, harder still. True north is not where the sun sets. It's not where your shadow points at any random time. It's a direction defined by Earth's rotation axis, an abstract concept you only see if you know how to use the sky. And yet, there it is in the stone. So you dig deeper, and the implications expand. If builders could align to solstices, they were tracking the year. If they could track the year, they could coordinate labor at scale. If they could coordinate labor at scale, they had organization, planning, and knowledge transfer. Not just one clever person, a tradition. And once you admit that, you start seeing surveying everywhere. Angles, sightlines, long straight causeways, paired stones acting like frames, points on the horizon chosen because a peak or notch makes a perfect marker. The landscape itself becomes an instrument. The more you investigate, the stranger it gets. Because the sky isn't perfectly stable. Earth wobbles. It precesses, like a spinning top, slowly changing where the stars appear over millennia. The position of the solstice sunrise on the horizon drifts slightly with changes in Earth's axial tilt. Even the moon is complicated. Its extreme rising and setting points shift over an 18.6-year cycle, the lunar standstill. And yet, Some sites appear to encode these longer rhythms. Researchers have argued that certain stone circles and alignments in Britain and Ireland relate not just to the sun, but to lunar extremes. It's debated, but the possibility alone is wild. That people without writing might have tracked a cycle longer than a childhood. How do you do that without losing the thread? You do it socially. You turn it into ritual. You embed it in story. You make the measurement sacred so it will be remembered. Now the investigation brings in real authorities, and they don't all agree, but they all take the question seriously. In the 1960s, engineer Alexander Thom measured hundreds of megalithic sites and proposed that builders used a standard unit, the megalithic yard, and had sophisticated geometry. Many archaeologists criticized his conclusions, arguing the data could be interpreted more loosely. But the debate itself changed the tone. It forced people to admit these weren't random piles of rock. Archaeoastronomy became a field. Astronomer Gerald Hawkins used early computers to test potential alignments at Stonehenge, suggesting astronomical intentions. Later studies pushed back on how many alignments are meaningful versus accidental, because if you have enough stones, some lines will point somewhere significant just by chance. But some alignments are hard to dismiss, like Newgrange's winter solstice beam, which has been directly observed and documented for decades. For the pyramids, historians and astronomers have offered practical methods ancient Egyptians could have used. One is called the simultaneous transit method. Observe two circumpolar stars and note when they align vertically. That vertical line can mark true north. Kate Spence published a well-known paper in Nature in 2000 proposing a version of this idea and linking it to dating pyramids by precession. Not everyone accepts the details, but it shows mainstream scholarship treats astronomical surveying as plausible. So yes, qualified people have considered it, they've tested it, they've argued about it, they've tried to reproduce it. And then, right when you start to feel like you've uncovered a lost civilization of sky surveyors, the story shifts. Because the dominant scientific explanation is less mystical and more human. Most experts don't think prehistoric builders had secret precision tools. They think you're seeing what happens when patient people use simple methods over long time spans and when modern viewers underestimate non-literate knowledge. Start with the easiest technique, shadows. A vertical stick in the ground, a gnomon, creates a moving shadow. Mark the tip of that shadow through the day and you can draw an arc. Do it morning and afternoon and you can find an east-west line from the symmetry. From east-west you can make north-south. No compass, no stars needed, just sun, stick, and time. For night methods, you don't need to know astronomy the way a textbook means it. You just need repeated observation. If a star never sets, it's circling a point. That point is near north. Track it long enough and north stops being abstract. Then there's the biggest twist of all. Not every perfect alignment is actually perfect. Measurements depend on where you stand, on what parts of a ruined structure you choose as reference points, on how much the ground has shifted, on restoration, on erosion, on whether the builders cared about true north or magnetic north or a landmark on the horizon. And humans are pattern finders. When you look at a complex site with an expectation of meaning, you can draw a line between almost anything and find a date, a star, a sunrise. Archaeologists warn about this constantly. With enough potential sightlines, coincidences multiply. So the same facts, stones pointing somewhere, passages catching light, can be interpreted in two ways. Either ancient people had astonishing surveying abilities, or they had good enough methods plus a few standout successes that survived, while the failures disappeared. Maybe the mystery is that prehistoric builders were impossibly advanced. Maybe it's that you've been taught a narrow definition of technology. But the conflict doesn't go away. Because even simple methods don't automatically produce massive precision. Finding cardinal directions with a gnomon sounds easy until you try it accurately. The sun's shadow blurs. The ground isn't level. The stick isn't perfectly vertical. Clouds interrupt. Over long distances, lines drift. And when you scale up to monuments that must be aligned across dozens of meters, tiny errors become big ones. Also, why build with alignment at all? If it's only practical, why make it monumental? Why enshrine it in stone? Mainstream explanations can account for the mechanics, but motivation is harder. The urge to lock time into architecture, to bind a community to the sky, this is not just engineering. It's worldview. And the alternative theories have their own problems. Claims of global ancient superscience often ignore local context, independent invention, and the messy realities of archaeology. Precision doesn't require lost continents. It requires dedication, observation, and a reason to care. So you're left in an intellectual gray zone. On one side, the temptation to romanticize, ancient surveyors with secrets, measuring Earth like a cosmic blueprint. On the other, the temptation to dismiss, lucky alignments, overinterpreted stones, myths projected onto rubble. The truth is probably stranger and more ordinary than both. Imagine being part of a community that returns to the same horizon year after year. You learn the sun's habits the way you learn a friend's face. You notice the day the light hesitates before turning back. You feel the year like a breath. And then you mark it, not with a calendar, with a building. A monument is a memory that doesn't die when your elders do. And maybe that's the real precision, not just in degrees and angles, but in continuity. In keeping an idea intact across centuries without paper, without screens, without databases. You call it architecture, they might have called it time. So when you stand in front of these ancient sites and feel that chill, like someone reached through millennia and pointed, you're not necessarily seeing impossible science. You're seeing what happens when attention becomes tradition, and tradition becomes stone. And the question that remains isn't only, how did they aim so precisely? It's why you ever stopped looking up long enough to forget that the sky is still drawing lines for you, every day, whether you notice them or not.